This question is from the 2009 higher level DCG paper and it's question A1. 3D graphic below shows a beam of light shining across a table top and generating a hyperbolic curve. The drawing on the right shows the axis, directrix and focus of such a hyperbola. The eccentricity for the curve is 1.2. Now 1.2 as a fraction would be 5 over 4. No, sorry, 1.2, it'd be 6 over 5. And we know that the eccentricity line for a hyperbola has to be greater than 45 degrees. So locate the vertex and draw a portion of the curve. So if it's greater than 45 degrees and 1.2 is a fraction of 6 over 5, I'm going to be measuring out 5 and up 6. So I can measure out 5 centimeters and go up 6 centimeters to get the angle of the eccentricity. So that's my point there. So that'll be my eccentricity line now going up. So to get the vertex then, I use my 45 degree set square from F up to the eccentricity line and then straight down to the axis. So that gets me V. Then same method as usual, I'm going to extend the line F and then plot out a number of points here on the side. Now they don't have to be measured, just once I have a variety of points, and I'll do one in the middle there as well. I'll probably go to the end of the line here. Each of those lines then go up to the eccentricity line. And then they go across to the focal line. One on this side. And then I'm going to use my compass, set my compass on F, mark up the height on the vertical line and swing it back to the vertical one there. Okay, that gets me a series of points. I can just join up the points where F, the line F meets the eccentricity is a point there as well. Okay, so that's my hyperbola. I can then mirror the points down to the bottom. And draw it in down here as well. Okay, that's part A of the question finished. Part B, determine the center of curvature for a point on the curve which is located vertically above the focus. So that's this point here. They want the center of curvature for that. Okay, so first thing you need to do is to get the normal line from that. So if that point touches, that's quite an easy point to use because the eccentricity here is the tangent at that point. So the normal here will be if I just set up my set squares along it and draw a line perpendicular from it. So that's my normal line. And then to get the center of curvature, you draw a line from that point through F and extend. So we have our F line there to begin with. And then where the normal line hits the axis, I'm going to go at 90 degrees from that point. That gives me a point on that line, and then I go 90 degrees the opposite way. So set up my set squares that way. 90 degrees then going back gives me the exact point for the center of curvature. So the important angles there is that that's at 90 degrees and that one there is 90 degrees. Now what is the centre of curvature? If you put your compass there, scribe an arc to the top, it'll draw a small portion of the hyperbola there, using that as the centre point. Okay, and that's your question finished.